Today we're going to solve absolute value equations. So solving absolute value equations is taking an absolute value and solving for the specific x value. So in the first scenario here, we have the absolute value of x is equal to a. So we want to think about, well, what are we trying to figure out when we're saying that it's equal to a? Because the absolute value is the distance from 0. So if I take the absolute value of 3, that's equal to 3, and the absolute value of negative 3 is also equal to 3, because that is the distance from 0. Negative 3 is 3 units away from 0. Positive 3 is 3 units away from 0. So the absolute value is the distance from 0. So x can take on a couple different forms. So when we have the absolute value of x equal to a, we are going to take x and set it equal to a. And we're going to take x and we're going to set it equal to negative a. Just like how I was saying here, where 3, the absolute value of 3 is positive 3, and the absolute value of negative 3 is also positive 3. So there's multiple values that can be the solution. So that's what we are doing when we are solving absolute value equations. We're going to take two separate equations, because there could be multiple x values that can make this statement true. So number 1, the absolute value of 2x minus 1 equal to 5. I'm going to take 2x minus 1 equal to 5, and 2x minus 1 equal to negative 5. So we're going to solve both inequalities here. Oh, sorry, not inequalities. Absolute value, just equations, I guess. So 2x equals 5 plus 1 is 6. Divided by 2. X is equal to 3. So that's one potential solution. And then on this one, I'm going to add 1. So we get 2x equals negative 5 plus 1 is negative 4. Divided by 2. X equals negative 2. So those are the two x values that can make this a true statement. And look what happens. If I take negative 2, just want to show you what happens. I have 2 times my x value that I just solved and got negative 2, minus 1, absolute value equal to 5. 2 times negative 2 is negative 4, minus 1. Absolute value of negative 4 minus 1 is the absolute value of negative 5, equal to 5. Absolute value of negative 5 is 5. 5 equals 5. See how that ends up working out? Same thing with 3. If I were to do that one, 3 times 2 is 6. 6 minus 1 is 5. Absolute value of 5 equal to 5. 5 equals 5. So we could have two potential solutions there. So it's x equal to 3 or x equal to negative 2. The one key component, though, that you want to keep in mind is when we set it equal to the a and the negative a. The important piece you want to make sure you're following is that the absolute value needs to be by itself before you do that second step of set it equal to a and negative a. So on number 2, the absolute value is not by itself. I want to subtract 6 from both sides. I get the absolute value of 3x equals 9 minus 6 is 3. So I get 3x equal to 3. 3x equals negative 3. Divided by 3, x equal to 1. Divided by 3, x equals negative 1. So nothing too crazy there. So x equal to 1 and x equal to negative 1. But the key here is getting that absolute value by itself before you take the positive and the negative. Or not necessarily positive, but just taking the original and then the negative. Number 3. 15x plus 15, absolute value, is equal to 0. So my a value here is 0. But I don't have, look, it's not 1 where I'd set it equal to 1 and negative 1. It's just 0. So the only potential solution that I'm going to find is 15x plus 15 equal to 0. That's all I need to do. I'm just going to set up one inequality because we are not going to be taking the absolute value of a negative number or a positive number because we want it to just be 0. So we're just going to solve this. Subtract 15. 15x equals negative 15. Divide by 15. X equals negative 1. So the only value that's going to make that true is negative 1. Because 15 times negative 1 is negative 15. Negative 15 plus 15 is 0. Absolute value of 0 is 0. So there's only one potential solution that's going to give us back a true statement there. Number 4, absolute value of 3x plus 5 plus 10 equal to 1. So now notice right away that the absolute value is not by itself, so we want to subtract 10. Get the absolute value of 3x plus 5 equals 1 minus 10 is negative 9. Now I have the absolute value of 3x plus 5 equal to negative 9. The absolute value equal to a negative number. I cannot take the absolute value and get back a negative number. It's not going to happen. So in this case, since I have the absolute value equal to a negative number, there is no solution. Or the empty set there. You can't do it. You cannot take the absolute value of a number to get a negative. You get 0, you get a positive, but you cannot get a negative, so there's nothing that we could do there. Number 5. The absolute value of 9x minus 6 equal to the absolute value of 3x plus 6. So we have the absolute value equal to an absolute value. So here's how we want to combat this. Now, first of all, the absolute value of 3x plus 6. We want to just leave that as the absolute value of 3x plus 6, like right now. Like if I go down to, just want to show you what I mean. Like number 7, if you look at this problem, see how I have the absolute value of negative 12? On that problem, I could take the absolute value of negative 12 and get positive 12. So I don't necessarily need to worry about the absolute value of negative 12 because that's just positive 12. So just something to keep in mind. But here with 3x plus 6, the x value can take on a couple different values. So we have to be careful. So here's how we're going to deal with this. When we have an absolute value equal to an absolute value, I want to take 9x minus 6 equals, I'm going to take the positive of 3x plus 6. And then I'm going to take 9x minus 6 equals the negative of 3x plus 6. So I'm taking both positive, just like how we did back on these scenarios here, where I had it equal to 3. I set it equal to positive 3 and negative 3. So the absolute value of that. So here, same kind of concept where I'm taking the positive of this and then the negative of that. And the reason I put this in parentheses, like minus parentheses 3x plus 6, is so you identify that this is going to be minus 3x and minus 6. And I'm taking the opposite signs on that whole entire statement there. So let's go ahead and just solve both of these. I'm going to subtract 3x from both sides. 9x minus 3x is 6x minus 6 equal to 6. Add 6 to both sides. 6x equals 12. Divide by 6. X equals 12 divided by 6 is 2. Then on this one, I'm going to have 9x minus 6 equals, that's going to be negative 3x minus 6. Go ahead and solve. I'm going to add 3x to both sides. 9x plus 3x is 12x minus 6 equals negative 6. Add 6 to both sides. 12x equals negative 6 plus 6 is 0. Divide by 12, x equals 0. So my two solutions are x equal to 0 and x equal to 2. And it's funny how this works because if I take 0, for example, let's just try out 0. I want to show you what happens. So this is 9 times 0 minus 6 equals 3 times 0 plus 6. 9 times 0 is 0. 0 minus 6 is negative 6. So I have the absolute value of negative 6. And then over here, the absolute value of 3 times 0 is 0. 0 plus 6 is 6. The absolute value of negative 6, positive 6. The absolute value of positive 6, positive 6. See how that worked? It's kind of weird how we end up with two different values, but since we're taking absolute value, they end up being the same. So that's why we would manage it that way. Number 6, the absolute value of x minus 3 plus 3 equals 4. So I'm going to subtract 3 from both sides. I get the absolute value of x minus 3 equals 4 minus 3 is 1. Absolute value of x minus 3 equal to 1 is going to be x minus 3 equals 1, and x minus 3 equals negative 1. So I'm going to add 3 to both sides. So I get x equal to 4. Then I'm going to add 3 to both sides here. So x equals negative 1 plus 3 is positive 2. So those would be my two potential solutions. 7 I already was kind of talking about. 7, I have the absolute value of 2x minus 10 equal the absolute value of negative 12. So different from this one, where on number 5 I had an x value on the inside of that absolute value. But on this one, it's just the absolute value of negative 12. So what is the absolute value of negative 12? It's positive 12. So I'm just going to take the absolute value of 2x minus 10 equal to positive 12. What do we do when we have the absolute value equal to a number? We take 2x minus 10 equals positive 12. And we take 2x minus 10 equals negative 12. So we just set up the two equations just like how we did before. So I'll add 10 to both sides here. 2x equals 22. And then I'll add 10 here. Guess I probably should have just finished up solving that, but that's okay. 2x equals negative 12 plus 10 is negative 2. Divide by 2, x equals 11. Divide by 2, x equals negative 1. So nothing complicated, just identifying that the absolute value of negative 12 is just 12. So then we just get the same type of problem there. Then I wanted to throw in one fraction here. Doesn't make it any more difficult, just wanted to throw this in here, just to make sure you know how to solve it. The absolute value of 2x minus 7 over 5 is equal to 3. So we'd set 2x minus 7 over 5 equals 3. 2x minus 7 over 5 equals negative 3. And then the solving. Multiply by 5. 5's cancel. 2x minus 7 equals 15. Plus 7 plus 7. 2x equals 22. Divide by 2. Kind of running out of room here. X equals 11. 22 divided by 2 is 11. So x equals 11 is 1. I'll go over here. Multiply by 5 again, but this time it's going to be 2x minus 7. So multiply by 5. 2x minus 7 equals negative 15. Add 7. Getting a little close to my camera. 2x equals negative 15 plus 7 is negative 8. Divide by 2. X equals negative 4. So the solving process is exactly the same as any other problem. We have the absolute value equal to a number, set it equal to positive, negative, and then you solve both of the equations, and then there are your solutions. So hopefully this wasn't too bad. I think the original concept of the absolute value is what is the struggle, but once you get that understood and you get that down, then the rest of it is just a lot of solving equations. So hopefully this went okay.